Alright, we're going to take a quick look at solving multi-step inequalities. So we looked last week, a little bit last week, week before as well, with the play coming in. We looked at solving single-step inequalities, much like solving equations. And the same thing here. Solving inequalities is like solving equations. The one difference is if you multiply or divide by a negative. So let's just get rid of that, and I'll just type that in. That'll just be quicker for me and easier to read for you. Multiplying or dividing by a negative number causes the direction of the inequality to switch. Right? So if it was greater than, and I divide by a negative, it flips over to less than. But yeah, that direction will switch. All right, that's the big difference. The other difference we'll get to when we verify or check our solutions. But let's take a look at the first one here. Let's scroll down so we can actually have some space to solve the first one. All right, so x over 4 plus 3 is greater than 8. Now, if we pretended this is just equals to 8, what's our first step that we do? Well, first thing we got to do, we're going to get rid of this plus 3. We want to get the thing with the x by itself. All right, so here, rewriting it and showing that first step, x over 4 plus 3. How do I undo that, essentially? I'm going to subtract 3. And that's greater than 8. And I got the same thing to this side. Subtract 3. Lovely. I am left now. X over 4 is greater than 5. Alright, so now I'm looking at, okay, how do I undo this bit? Well, I'm dividing x by 4, so opposite of that is multiply by 4. So I'm going to multiply both sides by 4. And I'm left here with x is greater than 20. So to show this algebraically, there it is. Graphically, I'm going to put that on a number line. I'm going to do a very small one just because I need room to do the check. But if this is 19, here's 20, here's 21. It's great. So anything bigger than 20, and if we have it set up so the variable's on the left, then whatever direction this inequality, in this case the greater than sign, is pointing, it means that the arrow also goes as if that's an arrow pointing it, right? And there we go, right? So here we go. It's a greater than sign, not a greater than or equal to, so it's going to be a hollow circle. And shade across the top, showing that from 20, not including 20, but from 20 and bigger, all values of x, if I've done this correctly, should satisfy this inequality. So when I do my checks, first check, I got to check the boundary points, right? And so this one, I'm really just assuming, or I'm treating it, I should say, I guess, as if it were a equation. So I want to make sure if I put in x equals 20 into this equation, will the left side equal the right side? Because if I've done that, the boundary point is correct. So x over 4, so I'm going to put 20 is my x value divided by 4 plus 3. Got nothing I can do with the 8, so I'm just going to leave it there. This 3 is not exceptionally pretty, but I think we'll be okay there. Order of operations says I got to do the division first. So 20 divided by 4 is 5. And we can already see, yeah, I did it right. 5 plus 3 is indeed 8. So now my boundary point is good. My next thing I have to do is I got to verify the solution in terms of, do I have the direction of this inequality right? Was I supposed to, for some reason, flip it? So now I'm going to pick a number for x that is greater than 20. And I am going to pick a number strategically. I am going to pick a number I know is divisible by 4. I could pick any number I wanted. I could put 37.8736952. But that would be sort of silly, because then I've got to do some unpleasant division. Let's rather pick a number that is going to be nice. So my boundary point is good. Let's try another check. And you know what number? I really like this number. Because I can divide it by 4 very quickly and easily, and that number is 40. It meets the criteria that it is indeed bigger than 20. It would be somewhere over here on my, way over here, on my number line. And so let's just check and see. So if I've done this correct, when I put in my number that's bigger than 20, so in this case it's going to be 40, because I can divide 40 by 4 really nice and quickly. 40 divided by 4 plus 3. 40 divided by 4 is 10, plus 3, that looks like a 7, and it's not supposed to, plus, that's a plus sign. 10 plus 3 is 13. Now I look back here, is 13 greater than 8? Yes, it is, which means I've done the direction right. So the boundary point is good, the direction is good. I have shown my solution algebraically, I have shown my solution graphically, and I have verified it both boundary point, right here, as well as over here. I have shown that indeed the direction of the inequality is right. Lovely. Let's move on to the next one. Scroll down just a little bit. This is a little bit more exciting. Not exciting because it's really hard, but exciting in that there's just a little bit more to do with this one. So in this case here, I've got a variable on both sides. I've got a constant on both sides. Variables on both sides, I can deal with this, not a big deal. We have to decide, I guess, which side we want to put the variables on. As I look at this, sometimes I don't like to deal with negative numbers, so I'll avoid them if I can. But in this case, I look at this and realize, well, I can subtract 5x from both sides. I'm going to get negative 8x over here. And then I'll be adding 10 here. I'll get positive 48 on this side. It's probably just as easy, because if I subtract, if I want to move the variables onto this side, I'm going to end up with subtracting 38 from both sides. So there's going to be negatives either way. So let's just go this way. So I'm going to subtract, first of all, 5x from both sides, and that's going to remove it from this right-hand side. So let's do that, and I'm going to break this down. You could subtract 5x and add 10x in the same step. I'm going to show it separately, just so that you've got it down in your notes. Just to make sure you're not getting mixed up. So negative 3x, I'm going to subtract 5x because I know I'm going to get rid of it from the other side. Minus 10. And this is less than or equal to, well, 5x minus 5x. I know it's going to go away. I should still record what I'm doing. Show my work. Plus 38. Lovely. Alright, so on this side, 5x minus 5x, it's going to go away. Negative 3x minus 5x is going to become negative 8x. Now I've got to subtract 10 on this side. I want to get rid of the subtract 10. The opposite is add 10, so let's do that. And if I'm going to do it to this side, I got to do it over here too. Now 5x minus 5x, that simplifies down to nothing. So now I've got 38 plus 10. All right. So at this point, it's actually simplified up pretty nicely. Right, I've got negative 8x left on my left-hand side is less than or equal to 48. Happily, I can see that 48 can easily be divided by 8 and give me a nice answer. So I'm going to divide both sides by negative 8. Now what happens if I divide this thing by negative 8? Given that it's an inequality, this sign is going to flip. So as soon as I divide by negative 8, this becomes x is not less than or equal to, but greater than or equal to. 48 divided by 8 is 6. Positive divided by negative is negative, so this will be negative 6. All right. So just says to solve it. I don't have to put it on a number line to graph it. Pretty easy to do. If I graph this guy, it's going to be a solid circle around the negative 6 because this is a greater than or equal to sign. All right, so we're going to check our boundary point first. Now this is one where we actually got to do something to both sides. Negative 3x minus 10 and 5x plus 38. And so I'm going to put in negative 6 every time I see an x. So negative 3 times negative 6 minus 10 and 5 again times negative 6. And I'm checking for boundary points, so I do hope that both sides end up being equal. If they don't, it would appear I've done something wrong. Negative 3 times negative 6 is positive 18. 18 minus 10. I'll just finish simplifying. This side is going to be 8. On this side, I've got negative 30 plus 38. And that's negative 30 plus 38 is going to be 8. Hey, everything works out nicely there. My boundary point is good. All right. Now, I am going to pick a value for x that is greater than negative 6. And I'm going to pick this strategically because I like easy. All right? And you should like easy too when you're doing checks on these things. All right? Now, the nice thing about this, did you know that 0 is bigger than negative 6? And multiplying by 0 just is wonderful. So now I am going to plug this x is equal to something bigger than negative 6. Again, I'm going to pick 0 because that makes for easy multiplication. Back into the original inequality. And when or if I've done this correctly, and I pick a number that is bigger, greater than, or equal to negative 6, in this case I want it to be greater than, my original inequality, this one here, should still be true. So I'm going to check it for x equals 0 because I'm lazy. And multiplying by 0 is easy. All right, so I will write out the whole thing so that you can see what we're doing. But doing this for yourself does just cut back on a little bit of the thinking. All right, so 5x plus 38. Basically, if you don't have to do extra thinking, don't. If you have to, be willing to do it. But if you don't have to, just don't. So negative 3 times 0. 0 is greater than negative 6. Minus 10 is what we've got on this side. Guess what 0 minus 10 is? It is negative 10. It's amazing. And then over here we've got 5 times 0 plus 38. Guess what 5 times 0 is? It's 0. What is 0 plus 38? It is 38. Then I look and see. Back to the original inequality, not my flipped version, but my original one, because that's where I plugged my value into. If I've solved this correctly, this original inequality will be true. Is negative 10 less than or equal to to positive 38? It certainly is. So negative 10 is less than or equal to 38, which means the direction check works as well. And that's really the gist of this one. Make sure when you're checking it, you show your work. We want to do boundary point. That's this first one we did down here. And then direction. Pick a number strategically. Pick a nice number, something easy to multiply. And that'll save you work when it comes to the work that you got to do later on. All right, moving on. Maybe. Yeah, there we go. All right, this is the worst of them, really. We've got some distributive property stuff. We've got variables on both sides. It's just kind of horrendous, but it's really not that bad. You can do this. Couple ways we can do this one. Most likely the way most people will do this is they will do the distributive property first. Right? Negative 2 times x, negative 2 times positive 3. And then you've got a question that's going to look very similar, actually, to what we just dealt with here, right? It's going to be a variable and a constant, variable and a constant. Go ahead and solve. We could, I suppose, divide both sides by negative 2 to start with, because I noticed that my coefficients here are both even numbers. So that doesn't give me any ugly numbers anyways, and I've got this negative 2 here. But it's not going to really save me a whole bunch of work. So I'm going to use the distributive property. So moving down my page, I have to multiply negative 2 by x. So I've got negative 2x. I have to multiply negative 2 by positive 3. So I'm going to have negative 6. So negative 2x minus 6. And my lovely inequality says that that is going to be less than or equal to 10x plus 18. All right, so now we got to figure out what we're going to do with the variables. In all reality, I'm going to have negatives no matter what I do. So let's move the variables to the left side and the constants to the right-hand side. How do I move the variables over here? Well, I'm going to subtract. I'm going to get rid of 10x. So I'm going to subtract 10x from both sides. So negative 2x minus 10x minus 6 less than or equal to 10x minus 10x plus 18. Lovely. Negative 2 minus 10 is negative 12x. We've got minus 6. I have to get rid of that minus 6. So what's the opposite? I'm going to add 6. So I'm going to get rid of that right away is here. 2 saves me one rewriting worth of things. 10x minus 10x, that's 0. That goes away. Lovely. I've got 18x. Or sorry, just 18, not 18x. 18 plus 6. And there we go. We've got negative 12x less than or equal to 24. And this works out kind of nice. 24 can be divided by 12 because that's the opposite of multiplying. So I'm going to divide both sides by negative 12. Ooh, I'm dividing by a negative. I got to flip this sign when I write it again. So I'm going to divide by negative 12. I'm left with x. And I flip the sign, so x has got to be greater than or equal to negative 2. All right, verify the solution. So we've got to do the boundary point business first. Let me do this up here. I have room. You have more room than I do because I know you write smaller. So we've got negative 2 and x plus 3 on the left side. And on the right side, I have 10x plus 18. Now, if I did this all correctly, if I plug this value in, I should end up with the same value on both sides. So let's do the work. -2 plus 3. Over here, I've got 10 times -2 plus 18. Alright, so here I've got -2 plus 3. Hey, that's 1. This is nice. So I've got -2 multiplied by 1, which I can do quite quickly in my head. It's -2. Over here, 10 times -2 is -20. Hey, this is going to work out nicely. -20 plus 18 is also going to be -2. That tells me my boundary point is right. So I can do algebra. Now let's check and see, is the direction correctly? Did I remember my rules for flipping variables, or sorry, flipping inequality signs? You can think back to this and say, yes, you did, but let's take another look. So again, we rewrite that. Oh, we got to pick a number that is greater than -2. Once again, I am lazy. Let's pick a nice number. Decrease the amount of multiplication we have to do. 0. 0 is a great value for x because it is greater than -2. So here we go. -2, we got to write the whole thing out again at the top. X plus 3. And again, once I put in this value, whatever it is that's greater than -2, if I did everything correct, the original inequality with the direction of less than or equal to is going to be a correct or a true statement. 10x plus 18. So again, here, if we look at this, x, I'm going to check this for x equals 0, because that meets this inequality, and it's a nice number. Okay, so we've got -2 times 0 plus 3. Well, that's easy. -2 times 0 plus 3, which is the same as really -2 times 3, which is -6. And then over here, we've got 10 times 0 plus 18. That doesn't look much like a 0, but you heard me say it, so it is. This is going to be 0 plus 18, which is just going to be 18. And then we ask ourselves, is -6 less than or equal to 18? Like our original inequality up here says, and yes, it is. Which means I passed the boundary point test. That's up here. Check mark for me. Passed my direction test. Check mark for me. Way to go. We've done this thing correct. All right. Moving along. Your turn. All right. I want you to solve these and verify. I am going to check that you've done the work on Wednesday. However, all right, so I'm gonna pause it here. I hit the button at the wrong time. Pause it here, check to see if you're doing this correctly, and then I'll check that you've done all the work on Wednesday. All right, so pause it here. If you haven't, do the work yourself. Solutions coming up. Oops. Try that again. So the first one is x greater than 6. Second one, my apologies there. I just want to make sure I do this and show you the right answer. And yes, x is less than -2 for the second one. Alright, so again, just so you got the answers, x is greater than 6 up here, x is less than -2 down here. Make sure you actually show your work and verify, but this is just to check that you've got them right. Moving on, we've got one more to look at. And here, this one I will show the full solution. We're going to use the distributive property really quickly. So 4x minus 8 less than or equal to 5x minus 12. Let's see here. I notice that I can do this without dividing if I subtract 4x from both sides, because then I'm going to get an x by itself over here. So let's do that. 4x minus 4x minus 8 is less than or equal to 5x. Ooh, terrible x. Minus 4x minus 12. I'm left with -8 greater than or equal to x minus 12. I'm going to add 12 to both sides to get rid of this. So let's just do that. And then, and this is kind of the backwards way of writing this, but it works. This is going to be 4 is greater than or equal to x, which I could then rewrite kind of in my more normal way of looking at things, saying that in fact x is less than or equal to 4. Again, you should show your check on that as well. All right, I'm going to stop the video here because even though we've got a couple of word problems here, if you get to the word problems, you can work on those and figure them out. But I want you to get working on just the math stuff before we get to word problems. We'll deal with word problems later. So enjoy, have fun, talk to you soon.